Hello everyone, I'm a gang. Finally, I still need to add a bit more knowledge for you. If you use a delegate, you can find something with the create suffix here, and you'll see it's consistent. Let's just click on one. Actually, the parameters here are the same as before, but its return type is a delegate type. Right, it's this type. So then you don't need to remove it like this. You can remove it like this. Remove it like this. For example, it should all be this type, right? Or use this. This simplest type. Remove it like this. We can create a lambda. The parameters passed here are all the same. We can pass a U object, same as this. Then, like this. Paste this over. Okay, so actually this place returns a delegate. A delegate, actually connecting it like this is a bit awkward. You can give it an A2, give a to or reference. Alright, writing this delegate can really be a pain sometimes. See if this can connect. It doesn't seem to work here. Let's see if we can connect it like this. This works good. So once we have a delegate here, then we'll do some minor operations. For example, I originally had a delegate here. We call it the replaced delegate. In fact, we can directly make it equal to it. Then this new delegate actually completes an override operation like this. I call this a minor operation. Sometimes I write it this way. That is, I don't want to unbind or bind. On the original delegate root, I just create a new delegate root and then directly replace it. Then we can do something. Then we can create a replacement code here. This part is completely fine. Then we can give it an O2 proxy root 2. We can use a function to expose this method, but only expose it to blueprint. Actually, here we are binding to my function. Then when it executes, this method is a bit convoluted. I'm tripping over my words. Okay. We call it call myself replace. Okay, so what do we need to do here? We just let it execute our last proxy. This is a slightly modified proxy. We directly let it execute if found. Obviously, what we are executing here is that this my function delegate is completely fine. So if I write another method here, let's call it call replace my delegate. Then actually I can write it like this. And I do it this way. We directly give a lambda. This makes it simpler. At this point, it shows one of the advantages of lambda. Create lambda. Then let's name it replace. And we'll keep this lambda simple. So don't include these slashes. We don't really like this whole setup. We probably won't write much related to macros. Right? We call this method replace. Okay. Then this part replaces this part. So let it execute. But actually, we haven't really replaced it yet. When we replace it, we just do it like this. We set it equal to this. Actually, we can expose this as a parameter here, but you'll see it's like this. How should we do it? Actually, this is quite troublesome. You can do it like this. Let's first take this just a little adjustment. I call it you can do it like this. It's just because replace in this. Then we create its implementation. No problem here. Then you just do it this way. Okay, no problem at all. The problem is that you cannot expose it to blueprint. This is a very awkward approach for you. This is because it is not dynamic, therefore it cannot be exposed to blueprint. So you can only do it this way here. Then here we bring a launch. Then this part cannot be exposed to blueprint. If you report difficulty, you will find that it won't compile. That you don't have it either. Don't overthink it. We adjusted the order here. We'll just do it this way. Okay, compiling this way is completely fine. You will find that this can be used to increase the call usage. So if you uncomment this part, we can take a look at this place. It will report an error like this. It is unable to find a class. The elegant annual extract with a lamb. This thing here is a native one. You can see it's not. That is to say, it's not using a strag. Nor is it a cast. Nor is it a dynamic delegate supported by blueprint. Nor is it every sentence. So here, you cannot wrap it into blueprint. Let me add a comment. This delegate is not dynamic. It cannot be used in blueprint, but it can be used in C++. Okay, now let's test it. Okay, this should be our current UNG-cast 1. Most of the content I can think of about what this underlying layer is, actually, it's a function pointer. Specifically, you need to look at things like the red ones in Unreal Engine. We won't be covering underlying knowledge in this kind of course. Then, if it's relevant, you can browse Jihu or other Bilibili creators. They have analyzed it. I really want to deduct 1 point here first. I'll deduct 1 point here first. Deduct 1 point first. This place should be deduct. So, replace. Let's execute the original first. Then next, we will. Core, replace, we replace it. Then we execute it again. This part is a bit tricky, but it shouldn't be a big problem. Let's take a look at what the execution effect looks like. Okay. Then you will notice, right? The function it executes is different. The first time this function is executed is burn from U function here. The second time it executes is repress. You will notice how it actually does it. Right before we call it, it went through this path here. Then after we repress delegates, it actually goes through this lambda. Okay, we have finally finished explaining unicast. It is still somewhat difficult if you haven't worked with it before writing it, but don't worry. We will use it frequently later on. Please try to follow along with this video tutorial, all the documentation, and practice more on your own. Okay, that's all for unicast. Thank you everyone.